Welcome to the video for the 9th through 13th questions on the example exam. In this one, we'll add an eccentric load to this tank and look at the resultant stresses at one end and the other, and the effects that has on the normal stresses in the longitudinal direction. We have an eccentrically placed axial load downward at 55 inches from the center of this tank. If we want to replace it with equivalent load at the center, we need to apply that 2,000 kips at the center and a moment that induces the same moment that this force does. So we can replace this load with a similar load where the moment is equal to the 2,000 kips times the eccentricity, which is 55 inches, which is going to give us 110,000 kip inches. So we can replace this tank with this tank. Which will make solving the rest of this much easier. We want to know about the stresses caused by this loading. So to do that, we're going to need to consider both the axial load, which is force over area, and we're also going to need to consider the bending stress. Which we find with a moment times the distance to the neutral axis divided by our second moment of inertia. Let's find our second moment of inertia now. The second moment of inertia for a circular cross-section is going to be equal to pi over 4 times the radius, the outer radius, to the fourth minus the inner radius also to the fourth, or in this case, because we've already found J, will be 1/2 the polar moment of inertia J, which means that this will be 459,573 inches to the fourth. We're also going to need our cross-sectional area. And that's just going to be, well, there's a couple ways to do this. This should give you pretty close results. We can use pi times, and I imagine this is how most of you guys did it, the outer radius squared minus the inner radius squared, just explicitly two circles, subtracting the smaller one from the inside. That's perfectly fine, you can do that. That's going to give you 113.2 inches squared. You could also find the circumference of the tank, which would be 2 times pi times the radius, and then multiply that by the thickness. And both of those should give you pretty good close numbers. That second one assumes that it's a thin-walled shape, but it's pretty thin. compared to its diameter, so you get good results with that. Anyway, we've got our cross-sectional area and our second moment now, which means that we can pop things into our equations. First, let's determine the maximum compressive stress. We're going to have our maximum compressive stress occur over here at this point, and we're going to have our minimum occur over here. Because over here we've got the axial load, of course, that's acting uniformly across the area, and we're also going to max out our stress due to bending moment. And then our minimum is going to be this over here. It's going to be where the bending moment is causing tension, but we still have this compressive load right here. So our maximum, so our compressive stress due to axial loads is just going to be 2,000 kips divided by our cross-sectional area right there, which is 113.2 square inches. That gives us 17.66 KSI. And then for bending, we're going to have our bending moment, which is 110,000 kip inches times the distance from the neutral axis out here to the farthest reaches, which will be 90.2 inches, divided by our second moment of inertia, which we said was 459,573 inches to the fourth. And that gives us 21.6 KSI. So our maximum and I guess we could put negative signs in front of that axial if we want, and then plus or minus in front of the bending, because over here it's compressive and over here it's tension. Anyway, our maximum compression is going to be equal to 17.66 KSI plus, because we're just going to add up all of the compressive loads, 21.6 KSI, which is going to give us, 39.25 KSI. That's our maximum compression, so negative 40-ish KSI if you like. And then our maximum tension is going to be that same axial load is still applied, that's 17.66. But now, because we're looking at tension, this is negative. But we still add 21.6 KSI, and that's going to give us 4 KSI. Or, I guess, 3.94. If that's really that important to you, but about 4 KSI. Oh. All right, so these are our maximum compressive stress due to the eccentric loading and our maximum tension due to the eccentric loading. Note that this is tension still, right? Because this is the axial load and this is the bending moment. So we do have tension in this tank due to that loading that's compressive loading. because it's so far from the center. Okay, now let's combine this stress with the other stresses that we've already found for this for the system. We have all of these stresses applied, some of them variously, changing their application at different points on the cross-section, so that when we're looking at this cross-section, we're going to have 2 points of particular interest. That's going to be where the bending stress is the maximum and the minimum. The rest of the tank is not going to have as extreme values as these 2 points. So, at the point where the bending is the maximum, we're going to have, already wrote up there, but our normal stress in the y direction is going to vary. At the point, so let's just look at 2 points. One of them, it will be y, our stress in the y direction maximum. That will be the least compressive, most tensile stress. In that case, it's going to be, using a different color, I don't like red, negative 17.66, okay, because that's compressive. That's compressive stress. Plus our longitudinal stress, 22.5 KSI, and then plus the bending moment stress, 21.6 KSI, and that is that's going to equal 26 point something, 26.5 KSI and some change. And we'll also have our minimum, and that is going to be, this stays the same, this axial load stays the same, this longitudinal stress stays the same, this changes direction. It ends up being negative 17.66 KSI plus 22.5 KSI, because that's the longitudinal stress from the pressure inside, and then minus the bending moment stress. Yeah, let's just label those. And this one, bending, 21.6 KSI. And so that is going to be that is going to be that's just about 1, so that's going to be negative 18 point, let's call it 18.7.